A meniscus is basically the curvature of the water, or whatever chemical substance is, inside of a glass cylinder. The reason why meniscus occurs is because water is extremely polar, and glass is somewhat polar. The opposites attract, causing the water to creep up the sides of the glass and causing that slight curve. The way that you read the volume of it is you count up 1, 2, the number of millimeters in which you're doing it, and you read it from the bottom of the meniscus. This is measured in milliliters and given in tenths of a milliliter. So I would read it the best I can to the tenth of a milliliter, and then I would estimate to the 100th place as where it lies in between the two lines. Alright, I'm going to draw water into the 10 milliliter pipette. I'm going to gather about 2 milliliters. Use my thumb to create a seal. Okay, I'm going to determine where the meniscus is and use that for my volume measurement. And that's a half, that's 1, it's about 1.4, I'm going to estimate 1.44 is my volume. And so, will somebody record that volume for 1.44 please? Milliliters. I'm releasing it into the beaker to be weighed. It's been released. I re-teared the scale. This is my 1.44 milliliters of water volume. I have already weighed the beaker, so I am now recording the volume of the mass of the beaker with the 1.44 milliliters of water, and then I will subtract the initial mass of the beaker from that to get my weight of the water.
So the mass of the water is 1.331 grams. We know that because that's the difference in the masses of the water-filled beaker and the beaker all by itself. Weighing the newly empty beaker to get a new measurement.
Because the beaker has some water droplets on it, it's going to increase its weight.
We're using a Moore pipette here. I'm going to shoot about 5 milliliters of water in this Moore pipette. And let's see how much I've got. I'm going to read the bottom of this meniscus here. Bring it up to eye level. And if this is 6 milliliters, that's 6.5. We're going to call this 6.60 milliliters of water. And I'm going to release 6.60 milliliters of water into this beaker. And there it goes. See how nice. Look how well I'm doing. Alright. Giving it just a shake. Always give a good shake. Alright, okay. Alright, we've got 6.60 milliliters of water here. We're going to weigh it. I've just tared the weights, the balance there. So we're going to get a new mass reading for this.
What is that showing us?
Okay, so we've got 32.280 grams.
I attempt to take about 4 milliliters of water sample from the graduated subject.
And you would have let out more.
Alright, now I'll try to take this and see exactly what I have. Okay, 2.8. Yeah, make sure I'm doing this right. 2.9 milliliters.
Now we're releasing the measurement into the beaker to be weighed.
Oh, and then I'm going down to...
tearing the balance. I'm going to reweigh this beaker to get an accurate measurement when it gets down to 0. If it gets down to 0. Try it one more time. Okay. So David, we're going to record this as 27.712 grams.
712. Yep.
We pulled out 8 milliliters of water. Meniscus is right. Under the 2 at eye level.
So at the bottom of this, you get exactly how many milliliters?
From the bottom, it's 8.8 milliliters of water.
8.80?
There's some that
Yes.
say 1 per person, and those are fine.
Now I'm pouring it.
And the notebook doesn't say that. One notebook per person.
Nice.
But you have to do every pipette step. You have to do every pipette step. And you have to
And then we have to record everyone doing it. So like for the video, does it need to show all 4 of us?
Excellent.
Well, let's just go over and measure this one.
This is the more pipette here, and between each usage, we washed it 3 times with distilled water and solution.
Alright, here we have our more pipette experiment. Down this column we have the 4 different volumes that we use. The first volume we used was a 1.44 milliliter volume. We measured that before we did anything. We measured the beaker, which we have listed in this column. The beaker on that first experiment with the 1.44 milliliter was at 27.622. We added the water and we came up to a mass of 28.953 grams. With that, we subtracted the beaker mass from the mass combined with the water mass, and we came up with a 1.331 grams, which gives us the mass of the water alone. From there, we determined our density, and our density was determined by the mass of the water alone divided by the volume which we started with, which was 1.44. As a result, we came up with 0.924 grams per milliliter of water, which is density. And we did the same experiment for the following volumes: 5.4, 2.8, 7.8, and we came up with the results of 0.843 grams per millimeter for the 5.4 volume of water. We have 0.982 grams per milliliter for the 2.8 volume of water, and we have a 1.0 grams per milliliter for the 7.8 volume of water, which is good because the density of water is close to 1.0 grams per milliliter, and according to our data, we were within range.